Hello everyone, welcome to the Somnia Developer Education Series, Somnia 101. In this session, we are going to learn how to use native STT on Somnia. Let's get started. The STT shop.so is going to have 4 functions. The first function will be the ability for the smart contract to receive payment. The second function will be the ability for a user to be able to buy an item. The third function will be for the owner of the smart contract to be able to withdraw from the balance. And lastly, would have a function to read the balance. Let's dive into writing our code. Solidity version 0.8.25. We'll call this contract STT shop. To begin, we'll declare a number of state variables and then a number of events. First, we want a data type of address set to public and called an owner. And then we want to have an unsigned integer to set the price for the item, and we will set this to 1 ether, which directly equates to 1 STT. And we want to also be able to track the number of items sold. So like I mentioned earlier, we'd have 4 different functions, each with 3 of them emitting different events for receiving STT for the items purchased and then for a withdrawal event. Before we write our events, we can go ahead and set up our constructor. The constructor will not take any arguments. We are going to have 4 different methods. First, the receive method. We're going to come back to write that event. Then have a function to buy an item, takes no arguments, it is external and payable. First, we need to set a require statement to check that the message, the value, which is the amount of native STT, is greater than or equal to the item price. If that isn't the case, kindly return an error, saying insufficient STT sent. Then once that is done, increase the count of items sold by 1 so that we can track it, changes, and of course we are going to also emit an event here. Then our third function, call this withdrawST. External, couple of checks to make sure that not just anyone can come and drain our smart contract. We have to make sure that the message.sender, which is calling the smart contract, is directly set to the owner. If that is not the case, return an error response, only owner can call this function. And what we want to do is have a variable balance. Here we set the address of the smart contract to balance. And we have to make sure that before we withdraw, our balance is of course greater than 0. If that is not the case, kindly return the response that no STT to withdraw. Then we have to increase the balance of the owner upon withdrawal by calling the transfer method and transferring the balance to the owner address. Once that is successful, we want to emit another event. And the last function here is to get the contract balance. So it's external set to view because it does not change the state of the blockchain, and we want to return an unsigned integer. So having done that, we just want to return the address, the balance of the smart contract by setting address this dot balance. So there wouldn't be any need to emit any event. So we have three events that we need emitted. We can go back to the top of our smart contract and write these events. So the first event that we want emitted, we call this received STT. What we want to see in the emitted event is the address of the sender, and of course the amount, which is an unsigned integer. The next event that we want to see emitted is the item purchased when the buyItem function is called. So we want to see the address of the buyer and also the amount paid. Last but not least, we want the event of the withdrawal made. What we want to see is the, of course, address that it was sent to and the amount. Now we can update these events in each of the functions. So for the first function, which is received, we want to emit received STT, and then we want to pass in the sender, which in this case is the message.sender, and the amount, which in this case is the message.value. And for the buyItem, we want to emit the item purchased event, and we want to pass in message.sender, and again the message.value. And for the last method with an event, we want to emit the STT withdrawn event, and we want to pass in the owner and the balance that was withdrawn. So now our smart contract is ready and it has automatically compiled. To deploy the smart contract, you connect to your MetaMask and set it to Somnia network. Then ensure that the deploying wallet address has enough STT to pay for gas. So we're just going to go ahead and click on deploy. So it will prompt us to approve this transaction via MetaMask. Confirm the transaction. So it is deploying the smart contract. You can see creation of STT, shop pending. The smart contract has been successfully deployed. And here we can interact with the smart contract. To interact with this smart contract, I would demonstrate this by using different wallet addresses. I'm going to change my address, so a different one. So this is a different address from the deploying address, and what I want to do is to first of all buy an item. So I can say I want to buy an item. You can see right now the contract balance is 0 and the number of items sold is 0. So called buyItem. That will prompt me to approve this transaction via MetaMask. Here I'll click on confirm, and then the buyItem is pending. So it successfully purchases the item. And if you check the contract balance, you see that it has increased by 1 STT. As you can see, the number of items sold has increased by 1. So typically with an ERC20 contract, I would first of all have to pass the contract address, approve the deployed smart contract to spend the tokens from that ERC20 contract before I would then be able to call the transfer method. But with native STT, you do not have to call approve and you do not have to call transfer. So this address is not the deploying address of the smart contract. And therefore, when I call buyItem, it is going to fail by sending this error prompt. I'm going to cancel this transaction, then change the address to the deploying address. And now you can see that the contract balance is 1 STT, and this is the original deploying address. You can confirm by calling the owner to see the address, and now we can call the withdrawST. This will prompt me to confirm this transaction on MetaMask, confirm the transaction, and we have successfully withdrawn STT from this smart contract without having to call the transferFrom method. So if you check the contract address, it's going to return to 0. And that is how we use STT on Somnia network, just as you would use it on the Ethereum network. And with that, we have come to the end of today's lesson. Thank you for watching to the end of this video. Kindly leave your questions, comments, and feedback. You can also ask your questions on Discord in the dev channel. I'm always available to answer. Like this video and subscribe to this channel. See you in the next one.